Alright guys, so this next video is going to kind of serve as an intro to rational functions. So rational functions, those are just fractions, but much of the fraction part, the rational function part of this unit is really like pretty easy to do. What is the difficult part of this unit is you need to have a very good Algebra 1 understanding. So really, like, it all comes down to, do you know how to factor, do you not know how to factor? Do you have a good number sense? Can you look at an equation and kind of see where it's going if you want to factor it, factor out a number, factor out whatever. So that's what I'm going to be working on here, because if you have this foundation, this unit should be really easy. If you don't, it's going to be really difficult. It's almost going to be impossible if you do not have this foundational understanding of factoring. So first off, with factoring, I like to think of almost like 4 types of factoring. The first one being just having an equation and factoring out either the greatest common factor, a number, a variable from that equation. So let's say we have 2x minus 10. I feel like this is the most simple type of factoring. What if I asked you, factor out the greatest common factor? Or I said, factor out the number 2. So you can factor out anything from this equation. All it means is you're rewriting this equation as something in parentheses, and then you have a number out in front that you're removing from that equation. And to figure out what's left inside the parentheses after you factor out that number, you can just kind of in your head divide this by this, and you'll get something here, this by this, you'll get something here. So let's say in this equation, and in most cases, I'm going to want to factor out the number that's in front of x. So how would I do that? The number in front of x is 2. So first things first, I'm just going to put a 2 on the front. And that's what I'm factoring out. So to figure out what goes inside the parentheses now, you're just dividing. We have 2 terms, we're dividing them both by the number 2. So 2x divided by 2 is just x. Negative 10 divided by 2, that's just negative 5. So we're just left with 2 times x minus 5. Let's do another quick one. Let's say we have 3x plus 6. We want to factor out this 3, so we write 3 out in front. Parentheses, 3x divided by 3 is just x. 6 divided by 3, that is just 2. So plus 2. Let's do some more examples. Let's say we have x squared minus 3x. There is no number for us to factor out, but there is an additional x. We have x squared and we have x. They both have an x. So if we wanted to, we could factor out an x from this equation. And when we take out an x squared divided by x, that just leaves us with x, 3x divided by x, just leaves us with a minus 3. So, like I said, with rational functions, it's not very procedural. It's not like you do this, then you do this, then you do this. But you need to have these kind of skills in your tool bag, so when you are in the mathematical field answering one of these problems, you can kind of say, okay, if I wanted to rewrite this, I could rewrite it like this. Just make little changes however you'd like. Okay, what about, there's a special case I want to introduce for factoring out a number. As I said, we can factor out any number. Let's say I had something like 3 minus x. Three minus x is weird. It looks kind of weird. We're used to having equations in standard form where it goes x and then it goes to number after that. 3 minus x is not like that. It gives us a negative x and the 3's up in front. We don't like it. So how could we rearrange this equation so that it's to our liking? And to do this, all you're going to have to do is factor. So as I said before, you can factor out any number from any equation. And kind of the magic number, if you have these 2 out of order, is negative 1. Because let's say we pull out a negative 1 from this equation. Well, we'd just be dividing both these by negative 1. And when you're dividing anything by negative 1, it just flips the sign. So this would now become a negative 3, but this negative x divided by negative 1, it becomes a positive x. So we divide both these by negative 1, we can almost like flip these two. Now x is positive, we can write it in front, and negative 3, we have minus 3. So you're also able to do that with these problems. Say we had, let's give you another quick example, 5 minus x. If we wanted to write that in the normal kind of clean form that we're used to, we just factor out a negative 1, and we're left with x minus 5. And you guys will see later, when we're doing these problems, x minus 5 is helpful to us. It's going to help simplify our equations. 5 minus x, not so much. So if we ever see something like this where the number goes before the letter, and we're given a negative letter, then know, okay, if I want to rearrange these, make the variable positive, I got to factor out a negative 1 from our equation. So that's the first type of factoring I wanted to get into. Now let's get into factoring where we have quadratics. So that was just for linears right there. Let's talk about quadratics. So first things first, with quadratics, we can do the same thing that we just did right here. So let's say we had like 2x squared plus 6x plus 8. Just because there's 3 terms, we're still allowed to take out the greatest common factor and move it up front. So if we wanted to factor in a 2, we could still do that. 2x squared divided by 2 is just x squared. 6x divided by 2 is just 3x. 8 divided by 2 is just plus 4. So that's still very possible for these equations. But now, I want to get into kind of traditional factoring that we're used to seeing like algebra 1. So this traditional factoring, it's kind of like you get an equation that's x squared something something something, and you rewrite it in factored form, which is just kind of 2 sets of parentheses. X something, x something. And this form is very, very crucial when doing these problems. So you need to know how do you factor an x squared and rewrite in this form. And there's 3 different kind of scenarios when we're factoring. So the first one is where we use a formula called difference of squares. So this is where we have an x squared up in front, and we just have a number after that. And that's going to be a perfect square. So let's say we have x squared minus 9. Whenever there's 2 terms and we're wanting to factor, we use this formula. A squared minus b squared equals a minus b times a plus b. So when you really understand this formula, it's super simple. So all it's saying is if you have a problem like this, you can suppose that x squared is a squared, and 9 is b squared. But to write it in factored form, we don't want a squared and b squared, we want a and b. So how do we figure out what a and b are? Well, a squared is just x squared. So if we want to find a, you just take the square root of both sides. These cancel out, and you just get that a equals x. Next, we have b squared is 9. Well, we want b, so say b squared equals 9. If we're trying to find b, we just do the same thing. Square root both sides, and you get b equals 3. So now we can just use this formula, and we can say that x squared minus 9, if we want to write that in factored form, it just equals x minus 3 times x plus 3. That's it. And so you don't have to do this every single time. I'm hoping with these problems you can just kind of eyeball it and say, oh, square root of 9 is 3, so it's just x minus 3, x plus 3. And I think you will over time. But I'll do a couple different examples just to kind of reinforce this into your brain. So I'm going to write down 3 examples. I'll give you a second if you want to pause the video and solve them. So let's say x squared minus 25. So I have 3 examples. If you want to try to do these 3 on your own, pause this right now. But now I'm going to get into them. So I'm just going to kind of fly through these because we don't need to do the work like we do over there. We should be able to just eyeball these and see for this first one, the square root of 25, that's just 5. So this is just x minus 5 times x plus 5. Same thing with this one. Square root of 49 is 7. So this is just x minus 7 times x plus 7. This one's a little trickier, but not really. The only additional step here is that instead of x squared, we have 4x squared. So a squared is now 4x squared. But what's the square root of 4x squared? Remember, when you're finding a square root, you just kind of go piece by piece. So the square root of 4 is 2. The square root of x squared is x. So it's just 2x. So our answer is 2x minus 6, parentheses, 2x plus 6. Another additional problem I'll do, just because I saw a lot of people messing up on this. You guys need to remember the square root of 1 is 1. So if we had x squared minus 1, this should be the easiest one. It's just x minus 1 times x plus 1. But unfortunately, I saw a lot of people messing up on that, so just want to make this clear. So when you get 2 numbers and one of them is x squared and you're asked to factor them, don't overthink it. Just take the square root of the second one and that's pretty much it. So this is the first type of factoring. So I'm about to erase it. You can take a picture of this, screenshot it, do whatever you like. Now I'm going to get into this second type. So this second type of factoring, this is where we have 3 terms. So let's say we have x squared plus 5x plus 6. We have 3 terms, but the number in front of x squared is just a 1. All we have to do for these is we make an x. And we put this number on top. And we put this number on the bottom. Again, this only works if there's a 1 in front of x squared. We do it like this. Now we think of 2 numbers that multiply to be this and add to be this. You just gotta do this in your head. Hopefully you have that number sense by now. It's just 3 and 2. And now we just pulled out these numbers and we write it x something, x something. And what goes in these spots are these 2 numbers. So x plus 3, x plus 2. And the sign comes along for the ride. So if this was a negative 2, or negative 3, this would be a minus 3. Negative 2, this would be a minus 2. But they're both positive, so you put pluses. These should be pretty easy, though, so I'm not going to go over too many more examples for this. Alright. Now we have one last type of factoring problem, and these are where we have 3 terms, but the first term is not 1. So let's say we have 3x squared coming up with this on the spot. So let's say we have 3x squared minus 8x minus 7x plus 4. 8x, or 3x squared minus 7x plus 4. So for these now, we still make an x, but this x is going to be a little different. On top of this x, you're going to put a times c. And you just remember a, b, c are just the numbers in front. So a, b, c. So on top you put a times c, 3 times 4 is 12. On the bottom you put b. On the bottom you just put negative 7. And now you're thinking in your head, once again, what are 2 numbers that multiply to be this top one and add to be this bottom one? And if you think little, you should get negative 4 and negative 3. This is negative 4 plus negative 3, negative 7, negative 4 times negative 3 is positive 12. Now the additional step here is you need to make a box. And inside this box goes these two terms. They go here and here. Interchangeable, either one. You could put -4 here, -3 here, it doesn't matter. And you put an x after them. And then in these two spots go these two. So 3x squared goes here, and 4 goes here. Now you're just solving a puzzle. So you're putting numbers and variables in these 4 spots right here, so that these two should multiply to be this, these two multiply to be this, so on. So I start off with this spot right here. In this spot, I take the greatest common factor of these two. So if I look at these, the greatest common factor of 3x squared and -3x, I get 3x. And from there, it's very easy to fill out the rest of the spots. So if this is 3x, this needs to be x, since x times 3x equals 3x squared. If this is 3x, then this needs to be -1. If this is x, then this needs to be -4. Then -4 times -1, 4, perfect. Now we just pull these numbers out, and we're left with x plus 1 times 3x minus 4. So I think what you should take away from this video is factoring is not hard. These problems are very trivial. All of you who are in my class, I know, are more than capable of doing these. But if you can't do these, you guys are going to see in the next couple of videos, it's almost impossible to do these rational function problems. So please, please, please engrave this in your brain. I posted practice problems on Schoology. You can do those, but please be prepared, understand how to do this, because if not, you're just going to fall behind.